Department of Mathematics, SNS College of Technology. Today we are going to discuss about the ANOVA table. So I chose the Latin square design, and in this I am going to discuss the ANOVA table alone. Okay, so based on that sum, we already derived between columns, between rows, between treatments and error. All the calculations are we derived already. So we are based on that we are framing one table, and in this we are fixing all the values. How to get the solution we can discuss now. So first is sum of squares, we can write it now. So sum of squares, SSC value is 4.69, and sum of squares of rows 29.19, and between treatments is 284.19, and the error calculation is also 11.87. And the next column is we can derive the degrees of freedom. So degrees of freedom for Latin square, all the rows and columns are 4 only. So we can have a common formula. So k minus 1. So 4 values, 4 data there. So 4 minus 1 equal to 3. Here also 4 minus 1, 4 minus 1, 4 minus. So after that, the error calculation. In error, the degrees of freedom for error is k minus 1, k minus 2. So k minus 1, that is total value, data are 4. So 4 minus 1 is 3, and 4 minus 2 is 2, and 3 into 2 is 6. Next, we can move on to the mean square. So mean square means nothing else. The mean value we are going to calculate. The mean value we can calculate using this, the numerator, sum of squares of columns, and the degrees of freedom. So we can write easily, this is in the numerator and this one is the denominator. Same thing for mean square between rows. So numerator, denominator, like that easily you can write for mean square between columns, between rows, between treatment, and as well as for the error also. So here what we are doing is, but we are calculating all those values, and here we have got 1.56, here 9.73, and then 94.73, and here 1.98. Up to this we are doing separately. After that we are going for the original calculation, variance ratio. So variance ratio nothing but that here we are going to calculate the calculated F, and then based on that we can calculate the table, using table we can calculate that value. Okay, so here that calculated, first we move on to that column wise. So column wise means we are using F test, that variance ratio test. So we simply call it as F test. So F based on that column, here the F test is formula is greatest value divided by smallest value. So we want to compare two numbers. So which two numbers we are comparing means column wise, mean square, column wise, and error. These two we are comparing. So which one is getting high value? Here 1.56, here 1.98. So 1.98 is the greatest value. So write in the numerator, and then smallest value write in the denominator. So the value is 1.27, which is greater than 1. So always you want to get the greater than 1. Okay. So here what I am writing, the error in the numerator and column in the denominator. The corresponding table value you want to get it means that error calculation degrees of freedom is 6, and column base value degrees of freedom is 3. So 6 and 3 you want to keep it in your mind. This numerator is error. So error degrees of freedom right here, first value, and then the second value is denominator value. So denominator column base degrees of freedom is 3. So you want to calculate the degrees of freedom for F test is here 5% level. So F 0.05. Take this table, and here numerator and denominator. So like this we are having. So numerator you want to check 6, and the denominator you want to check 3. So these two combined value is 8.94. This is the way you want to get the table value. So next I move on to the row wise. So row wise means here also the mean square as well as in the error. These two we are taking. So here the value is 9.73 and here 1.98. So comparing these two, the row wise is getting a greatest value. So write the row wise in the numerator and error in the denominator, and you will get 4.91, which is greater than 1. So after this you want to get the table value. So table value means here numerator value is numerator in row wise degrees of freedom is 3 and in the denominator error degrees of freedom is 6. So 3 comma 6, same thing, 0.05 F 0.05. Take this table, in numerator 3 and in denominator 6. Combine these two value and you will get this 4.76. Okay. So next I move on to the treatment. Same thing we are continuing with the treatment also. So here we are comparing for treatment and error. Here 94.73 and here 1.78. So here treatment is getting a higher value. So write in the numerator and error in the denominator. So calculating this value 47.84 we are getting, which is greater than 1. So we can conclude this is a calculated value. So same thing, treatment degrees of freedom is 3 and error degrees of freedom is 6. So 3 comma 6. So 3 comma 6 value only you want to get at the 5% level. So in this already calculated. So the same value I am writing here. It's 4.76. After this we can come to a conclusion based on this calculated value and table value. So which one is bigger? So always in conclusion calculated F is less than table F. Okay, so it's a basic thing. So basic value means here first for the column, table column, as well as calculator row wise and table row wise, and then calculator treatment as well as table treatment. So both we want to write simultaneously, and then I will write those values. Calculated value is 1.27, here 8.94. Always for all the sum the table value should be getting a higher value. So here the condition is satisfied, so we accept H0. And here for the row wise 4.91 and this one is 4.76. So this is original condition, here 4.9, here 4.7. The condition is not satisfied, so we reject H0. And the next one in treatment, this one is 47.84 and this one is 4.76. So this is original condition. Table value is getting a lesser value, so the condition is not satisfied, so we reject H0. This way we can conclude the sum. Okay, thank you.